Hello all, myself Mrs.Aishwarya Raikar. Today I am going to take the topic number system and their interconversion. So what do we mean by number system? Basically number system are nothing but what? The techniques which are we use to represent the number in the computer system architecture, and every value that we are using to get into computer memory for a defined number system. Now there are basically the 4 number system in our computer architecture. First is binary, second is octal, third is decimal, then the hexadecimal. Now let's discuss these one by one. First is binary. As the name indicates binary, it has only 2 digits, namely 0 and 1. Every number represents within 0 and 1. So as it is binary, it has a base of 2. Then decimal number system. Decimal has only 10 digits, that is from 0 to 9. Every number represents within 0 to 9 and it has a base of 10 as it has only 10 digits. Then the octal number system, as the name indicates, it has 8 digits that ranges from 0 to 7, and the number ranges from 0 to 7 and it has a base of 8. Hexadecimal, as the name indicates hexadecimal, it has total 16 digits and has a base of 16. But it has numbers from 0 to 9, and when it comes to 10 to 15, we do not write 10. We write A, B, C, D, E and F from 10 to 15. So this is a overall summary which describes the number system, its base and the digits. And here is the example of every number system. As we can see here, binary, its base is 2, used digits are 0 and 1, and the example is 1100. Octal, the base is 8, the used digits are 0 to 7. 360 to the base 8 is the example. Decimal, the base is 10, digits used are 0 to 9, the number is 24 to the base 10. Hexadecimal, the base is 16, the digits used are 0 to 9 and E to F, and the example is F0 to the base 16. Now let's move towards the conversion. Now whenever we are given a decimal number and we are supposed to convert it into binary, how to do that? Suppose the given number is 47. We will simply divide that number by 2. So while doing the division, the way we do the division in the mathematics, in the same way we will do it. We will write the remainder here, and while writing the answer from bottom to top, we will be writing the sequence. As we can see here, 47 divided by 2, 23. Remainder is 1, then 23 divided by 2, 11, again the remainder is 1, 11 divided by 2, the 11 divided by 2, the quotient is 5, remainder is 1, 5 divided by 2, the quotient is 2, remainder is 1, 2 divided by 2, the remainder is 0 with the quotient 1, and 1 divided by 2, here the quotient is 0 and the remainder is 1. When the quotient comes 0, here our division stops, and how we will write the answer from bottom to top. This is how we convert the decimal to binary. Now let's see how to convert decimal to octal. The number given is 1, 2, 3, 4, 5 to the base 10. Similarly, while converting a decimal number to octal, we will just simply divide that number by 8. And same sequence, you will just simply write the answer from bottom to top. In terms of decimal to hexadecimal conversion, again the same number we have taken, but here as we are converting that number into hexadecimal, we will simply divide that number by 16, and again from bottom to top we will be writing the answer. Now the next is binary to decimal conversion. Now I am given a decimal number and I am supposed to convert it into decimal. Then what we will do, we will simply multiply the digit of with the digit of power of 2, and eventually we will add all the multiplication which will give us the decimal number. See, here the given number is 110110001. So what we will do, we will start assigning the power of 2 from this last till first. That is, this is 2 raised to 0, this is 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6 and 2 raised to 7. And simply we will finally sum up these things, which gives us 217 to the base 10. So that is our decimal number. Then the next is binary to octal conversion. Now the easiest way to convert from binary to octal is just group the binary digits into the set of 3. Now why do we group it into the set of 3? Because octal. The base of octal is 8. Now when we do the power of 2 to the 3, we get 8. That's why while converting binary to octal, we always group the digits into the set of 3. Now let's see the example. This is the binary number given, 111 Now we will start grouping from the last. As we can see here, 101 100. Now as we can see here, 11 is there. 1 bit is less. So how we will complete that? We will just simply append 0 to make a group of 3. And now we will simply write the octal number for it. Here is a table which will help us. So we can see here, 101 in octal it is 5. 100 in octal it is 4. And 011 in octal it is 3. So this is how we convert binary to octal. Then binary to hexadecimal. Now, as the base of hexadecimal is 16, while converting binary to hexadecimal, as 2 to the power 4 gives us 16, that's why we will do the grouping into the 4 bits. Now, in the same way, if we are given a binary number, now this time we will do the grouping from the last into 4 bits. You will start grouping from the last and you will do the grouping into 4 bits. So the number is 111 So from the last I am starting 0100 and 1100, and simply let's find out the hexadecimal number of it. So 1110 is E, 0101 is 5. So E5 to the base 16 is the hexadecimal number we got. Now octal to decimal conversion. Now I am given an octal number and I am going to find out the decimal number of that. So what will I do? I will simply just multiply that number with the power of 8. So the number given is 345. So simply multiply it with the power of 8. So here we can see 3 into power of 8. So starting from the last to the first, we have started giving the powers. So finally we get the number 229 to the base 10. So here we can see for octal to decimal, what do? Is we multiply with the power of 8. Just now we have seen whenever we are given a binary to decimal, what do? Is whenever we are given a decimal number, how we convert it into binary? We multiply it with the power of 2. In the same way, while doing the conversion of octal to decimal, just simply multiply that number with the power of 8. Now hexadecimal to decimal. Now hexadecimal has a base of 16 and we are supposed to convert it into the decimal. So simply just multiply it with the power of 16. The logic is same. Here we are about to convert it into decimal, so simply multiply it with the power of 16. Here is the example 2C9B. So simply 2 into 16, 12 into 16, 9 into 16, 11 into 16. Start giving the power from last to first. So B into 16 raised to 0, 9 into 16 raised to 1, C into 16 raised to 2, 2 into 16 raised to 3. So this is the answer. Hexadecimal to binary. Now I am given a hexadecimal number. How will I convert it into binary? Simple logic is that just simply find out the 4-digit representation of every individual bit of your hexadecimal number. So what is the given number? A to DE. If this is the number, then A. In hexadecimal, A means 10. So simply find out the 4-digit representation of 1010. So how do we get E? So just refer this table for that particular chart. So E, what is E? 1110. What is A? Here we can see 1010. So this is how we convert hexadecimal to binary. And last but not least is octal to binary. While converting octal to binary, simply here we will be taking the 3-bit binary representation of every digit of octal number. So how do we represent 3? 011 is the binary representation of 3, 4 is 100 and 5 is 101. This is how we do the conversion. Thank you.